charms, festive season offer is back. So this is the best time you can go for this deal, 50% off on our CBSE subscriptions. So for that, you need to make use of the code UNLOCK and get 50% off on our subscriptions. So please don't miss it. Hey budding charms, we are back with our next one-shot session on the topic called some natural phenomena. So I hope everyone is doing well today. So let's get started. So my name is Aishwarya Sindhu Ramachandran and I will be your science educator today. So we are going to have a wonderful lesson. So please pay attention throughout the class and try to take down the important points. Not only that, if you find any kind of doubts in between, please don't hesitate to ask your doubts in the comment box. I'm here to help you out. So let's dive into our contents, and here you can see that we are going to start off with a very basic concept of electric charge. Then we will be learning interaction of charges. Then we'll learn methods of charging, charge detection, earthing, lightning, and finally earthquake. So these are the basic details that we will be learning today. I hope everyone is ready. Is it so? Yes? Okay, so let's get started and look at this. Oh, it's all about particles. Oh, what are these particles? Don't worry, let me break it down for you. So when you take any matter, oh, then you get a question. What is matter, right? Okay, so anything that has mass and volume can be called it as matter. This pen is a matter. My body is a matter. The water I drink is a matter, because all of these have masses and can occupy a space, and that is what the reason we call them as matter. So when you take these examples, apple can be a matter, paper can be a matter, water can be a matter. So all of these are considered as matter, and these are made up of tiny particles. Look at this. These are made up of tiny particles. So if I take one of the particles, you can see that this can be called it as atom. And now I'm going to show you the zoomed version of an atom. Oh, it looks so good, right? Okay, so let me tell you what the other particles can be seen right inside an atom. Atom itself is very tiny, and I can find a few more particles inside the tiny atom. What are they? Let's learn. So when you look at this, you can see that the center of an atom can be called it as nucleus. And what about P? P represents proton, which is nothing but the positively charged particle right inside an atom. And what about N? N represents neutron. So neutron has no charge, but it is actually concentrated inside the nucleus. And what about electrons? These are revolving around the nucleus through various orbits. So I hope you're clear with all the points what we discussed so far. And now what is the necessity of learning all these positive, negative together here? Oh, because we are going to learn about charges in detail. So charges are very, very important, because protons have positive charge, electrons have negative charge. And what about neutrons? Neutrons are neutrally charged, or it has no charge. Clear? So I hope everyone is clear. So we are going to learn a few more things about electric charge. So electric charge is nothing but the fundamental property of matter. So this is what the connection between matter and electric charge. So electric charge is considered as the fundamental property of matter. And what about its SI unit? It's Coulomb. You have to be very specific with the spelling of it, because a lot of people who can make a lot of mistakes here. And charge of an electron, look at it, it is minus 1.602 into 10 power minus 19 Coulomb. So C represents Coulomb here. And look at this is negative. That means electrons have negative charge. So minus 1.602 into 10 power minus 19 Coulomb. So this is nothing but the charge of an electron. And this can be used in various mathematical problems that we discuss in particular chapter. And what about charges of subatomic particles? That has been discussed already, and now we are going to just revise those things. Protons have positive charge, electrons have negative charge, and neutrons have no charge, or you can say it's neutrally charged. And now we are moving towards the next one. It's all about types of charges. Very, very, very important, because we are going to learn different types of charges here and how they actually behave. So when you consider the different types of charges, there are mainly two. What are they? Positive charge and negative charge. Okay, so how you can say an object to be negative? Very simple, and that's where we need to understand the number of protons and number of electrons. If an object carries a negative charge, what is meant by that? It has more number of electrons than protons. So electrons are negatively charged, protons are positively charged. If an object has more number of electrons, means it is negatively charged. Clear? Similarly, if you say an object to be positive, it has more number of protons than electrons, because electrons are negatively charged, protons are positively charged. So if an object has more number of protons, that means it is positively charged. So this is what you need to understand. And what if the number of protons and electrons are equal? How? They're equal, right? That means they are neutrally charged. Or you can say that it is neutral in nature. You have to be very clear with this. And now we are diving into the next one. It's all about interaction of charges, how they behave each other. Let's discuss that. So in the first scenario, I have considered two positive charges. That means they are similar charges. So when you look at this, you can see that both of them are positively charged. If I try to make them close, I can't. Oh my God, they are just moving away from each other. That means they repel because they are similar charges. So let's take the same scenario here. Both of them are of similar kind. So negative charge, negative charge. Again, if I try to make them close, I cannot do that. They repel, right? So they move away from each other. That is what the reason we call it as repulsion. So similar kind of charges can repel each other. And what about this one? This is a positive charge and this is a negative charge. So we have considered two different charges here. So if I try to make them close, they attract each other, right? So if you take dissimilar charges or different charges, what happens? They attract. So you have to be very clear with this point. Similar charges repel and dissimilar charges attract each other. So this is what the main point that you need to understand from here. And now we are moving towards methods of charging. Charging is very essential, right? Yes. So you can do it in mainly three ways. What are they? Charging by friction, charging by conduction, and charging by induction. So these are the main methods that can be employed to charge. So now let's learn it one by one. And here we are going to learn the very first one. It's nothing but charging by friction. And this is where you need to understand that you're going to rub two objects. Just try rubbing your hands. It feels so warm, right? Yes, because of the friction occurred in between the hands. And now we are going to learn more about it in detail. So look at it. A transfer of charge occurs when two objects are rubbed each other. So let me tell you another example here. Combing your hair with a plastic comb. This is also kind of charging? Yes, of course. How is it possible? Let's learn together. So the object loses electrons, become positively charged, and the object gains electrons, become negatively charged. I'll give you a small hint to remember these things. Okay, so if there are some needy people, we give our clothes and food to them, right? Because they're needy. So what we feel very positive after giving that, right? So that's the same way we need to think about it. So once you lose your electrons, you become positive. Once you gain electrons from somebody, then you become negative. Clear? So this is a way you need to understand. So if you lose electrons, you become positive. If you gain electrons, you become negative. And when you take the example of combing your hair, plastic comb is going to acquire a negative charge, whereas the hair acquires positive charge. Clear? So who has lost electrons here? Can anybody tell me who has lost electrons? Who has lost electrons? Hair has lost electrons, and that is what the reason it gained a positive charge. Clear? So I hope you're clear with all the points what we discussed so far. And now we are moving towards charging by conduction. This is the second method of charging. And you can see that bringing an uncharged object close to a charged object. So what is an uncharged object? It can be a neutral one. Okay, so I'm going to bring a neutral body close to a charged body. Okay, so that's the first thing that you need to understand. So look at the next statement. The excess charges from the charged body flows to the uncharged body and make it charged. How is it possible? So I'm taking a charged body and I'm going to take an uncharged body. So if I try to keep them close, what happens? The charge can flow and make the other body also charged. That is what the same thing which is happening here. So for the better understanding, I have made an amazing picture for you. So now let's learn. So charging by conduction, the same topic using a small diagram. That is what we are going to learn now. So here you can take that, a positively charged body. Okay, I have took a positively charged body here. Then I have an uncharged body. Okay, so uncharged body is nothing but neutral body. You have to be very clear with this. Okay, this can be a neutral body too. Clear? Okay, so I'm taking a positively charged body and an uncharged body. Got it? And now I'm going to make them in contact. Look at it. I'm going to make them in contact. So what happens? The charges can flow from this positively charged body to the neutral body when it comes in contact, so that it can also become a positively charged body. Got it? So this is happening in the part of charging by conduction. Similarly, I can take a negatively charged body too. Look at it. Here I have considered a negatively charged body. I have a neutral body too. So if I try to make them in contact, what happens? The charges can flow from a negatively charged body to the neutral one, so that this can also become a negatively charged body. Clear? So this is all about charging by conduction, and I hope you're clear. And now we are moving towards the third one, and look at it, it's all about charging by induction. So let's learn the statements here. Charging an object without actually touching to any charged object. So in this particular kind of charging, we are not trying to make them touch. So no physical contact is happening between the bodies here. And now a charged rod brought near to the neutral body creates a special arrangement of charges on the neutral body without touching it. Okay, so you're understanding the point, right? So I will give you a small representation on it so that you will understand it better. Don't worry, okay? For now, you can simply learn the statement. So charged body brought near to the neutral body creates special arrangement of charges on the neutral body without touching it, and charges removed through grounding and transforming it into a charged body. So this is called charging by induction. So when you learn this particular statement, you may have some confusions in it. So don't worry, that is why we have a representation here. So look at it, charging by induction. So similarly, I have considered a neutral body here. So what is a neutral body? It has equal number of protons and electrons. In that scenario also, we can call it as a neutral body. Correct? So this is what a neutral body is. And now I'm going to take a negatively charged rod nearby this neutral body. But I'm not going to make any kind of physical contact between them. No physical contact. Okay, so what happens? Now you can see that all the positive charges are getting accumulated to the one side, and all the negative charges are being accumulated to the other side of it. Now a few negative charges have been eliminated through grounding process. Clear? So now what is happening? More positive charges are existing in the body, and therefore this becomes a positively charged body. Clear? So I hope you're clear. Similarly, I'm going to take the second scenario, the same neutral body with equal number of protons and electrons. I'm just keeping a positively charged rod nearby this one, but I'm not going to create any kind of physical contact. Clear? Then what happens? I'm going to remove a few positive charges through grounding so that more negative charges can exist, and it becomes a negatively charged body. Clear? I hope you are clear. So these are the two ways in which you can make charging by induction. Clear? I hope you are clear with this part. Okay, so when you just learn these diagrams, it's super easy to learn these concepts. So now we are moving towards electroscope. What is meant by electroscope? Device which can be used to detect the presence of charge. If you want to find, or if you want to just detect the presence of charge, you can make use of this particular device called electroscope. So for example, I'm going to take a positively charged rod nearby this electroscope. So what happens? the charges can get transferred, and therefore both the leaves acquire the same type of charges. And what we learned earlier, if you have two bodies with similar charges, they repel each other. That is what the reason you can see that there is a repulsion. Look at this. They move away from each other. They are showing a divergence. Why? Because they are similar in charges. Similarly, I am going to create another situation where you can see a negatively charged rod has been considered. Again, the charges get transferred, so both the leaves acquire the same type of charges. Again, you can see they are diverging because both of the leaves acquire same type of charges. Clear? So they repel each other. So I hope everyone is clear, and now we are moving towards the next one. Look at it, it's all about discharged objects. What are these? The objects lose their charge by transfer. So if objects can lose their charges by transfer, this can be called it as discharged objects. And what is the method of discharging the charges? It's nothing but through earthing. So earthing is nothing but the transfer of charges from a charged object to the earth. So what is meant by earthing? Transfer of charges from a charged body to the earth. Clear? So here you can see an example of it. Look at it. This is a current supply. This is an electrical equipment. And it has two wires. What are they? A live wire and a neutral wire. So earthing has to be done from a neutral wire, whereas the charges are being transferred to the earth. Clear? So I hope you're clear with the part of earthing too. And now we are moving towards the next one. Lightning! Lightning can be very scary, right? Yes, but we need to learn it. And look at it. What is meant by lightning? So lightning is nothing but an electrostatic discharge. Oh, what is meant by that? If I tell you that the charge is being dissipated during lightning, do you agree with this? Yes, of course, you have to agree with this, right? So lightning is considered as a sudden electrostatic discharge between charged areas of cloud. Oh, so that means clouds can be charged. But how? During thunderstorms, air currents move upwards and water droplets move downwards. You have to be very clear with this point. See, during thunderstorms, air currents can go up, okay, whereas the water droplets can come down. Okay, so what happens? Due to this, the charge separation occurs. How? All the positive charges are going to be accumulated on the top of the cloud, whereas all the negative charges are going to be accumulated on the lower edge of the cloud. Oh, this is how the charge segregation occurs. And what about ground? Ground is positively charged. So we know that the negative charges can attract positive charges. But what is there in between? It's air. Air is a bad conductor. But due to the high accumulation of negative charges here, it can just get into the ground and attract these positive charges, and that is how the lightning strike occurs. And I hope you're clear. A very, very easy thing. So the positive charges collect near the upper edges and the negative charges near the lower edge of the cloud. And Earth's surface is considered as a positively charged surface here. So when more negative charges accumulate in the cloud, it starts to flow towards the ground and through air as lightning. So I hope you're clear. Very, very simple. So I will just repeat it for you. You can understand that. During thunderstorm, air currents can go up and water droplets can come down. Okay, so due to this, charge separation can occur. So all the positive charges can get accumulated in the upper edge of the cloud, whereas all the negative charges are going to get accumulated in the lower edge of the cloud. Then the ground is positively charged. So this negative charge can attract the positive charge here, right? That's what the scenario we learned earlier. Right? So the same scenario can occur here. All the negative charges are going to attract these positive charges. But what is there in between? It's air. So air being a bad conductor, but still you can see that the accumulation is very high. So what happens? It just gets into the ground like that as lightning. So this is how the lightning occurs. And now we are going to talk about lightning safety. So safety is also very important, right? Yes. So you have to check the weather forecast before going out. You have to be very cautious, right? Yes. Similarly, lightning conductors can be installed on tall buildings. Oh, what is that? Lightning conductor? Let's learn about it, don't worry. And lightning conductors can be installed on tall buildings so that it can ensure safety and prevents damage. And avoid open areas. If you are in an open area, just try to get settled in a safe area where you can stay from isolated trees, towers and electric poles. You have to be very clear with this. Avoid open areas and stay away from isolated trees, towers and electric poles. Okay, and now we are moving towards lightning conductors. Oh, what are these? That's what we are going to learn now. So you might have seen a lot of tall things that can be seen on the top of the tall buildings, right? These are known as lightning conductors, and this is nothing but the metallic rod, and it has been connected to the earth, and there is a copper plate through which the charges can be given to the earth itself. And this is actually a kind of safety precaution. So it protects building during lightning, and a metal rod is installed on the roof of the building, and it is connected to a copper plate buried inside the earth. So if there is a lightning, the metal rod can take all the charges and just transfer it to the earth. Clear? So when the charge cloud becomes in contact with the lightning conductor, charges flow through the metal rod to the earth and prevents damage. So this is how lightning conductors work. And look at this. It's all about earthquake. This is also a natural calamity, or you can say it's a natural disaster, right? And earthquake is nothing but a sudden trembling of Earth's surface due to disturbance in deeper parts of Earth. What is meant by that? So for that, we need to consider Earth's surface. So let this be our Earth. So Earth has surface. So these surfaces are constantly moving, right? These surfaces are constantly moving, and these are known as tectonic plates. Okay, so tectonic plates are earth crust fragments which are constantly in motion. Okay, and how this earthquake is formed? So there will be some kind of disturbances or certain kind of vibrations that can happen in the inner deeper parts of Earth. Clear? So this can create these tectonic plates to slide past each other or to collide each other, or it can create a lot of rifts or drifts in between the tectonic plates. So this is nothing but the reason behind the earthquake. So tectonic plates are nothing but constantly moving, and they can slide past or they can collide, and which can create earthquake, and it causes large scale damage to life and properties. So earthquake can be so dangerous. And how do we measure? It's in the magnitude of Richter scale. So power of earthquakes can be expressed in Richter scale. So tremors deep inside the earth produces seismic waves. So I told you, there are some disturbances right inside the deeper parts of earth. So these disturbances are nothing but seismic waves. So seismic waves produced by the tremors can cause earthquakes. So I told you that there are some disturbances or there are some vibrations that can happen right inside the deeper parts of Earth. And that is what the reason for earthquake, right? So what are these disturbances basically? These are nothing but the seismic waves produced inside the earth, and that is what the reason behind the earthquake. And now we are going to talk about seismograph. This is nothing but an instrument records seismic waves. Vibrating rod or pendulum starts vibrating when tremors occur. Very, very important. Clear? So an instrument records seismic waves, vibrating dot pendulum starts vibrating when tremors occur. So this is nothing but a seismograph is, and you can see that there are a lot of vibrations can be recorded in this so that you can understand how powerful an earthquake is. Clear? I hope you're clear with all the points what we discussed so far. And now we are going to talk about the safety precautions. Find a clear spot away from overhead lines and tall buildings and stay under a table till the tremors stop. So these are the two ways in which you can just make yourself safe during earthquakes. And now we are going to talk about the summary part, and we have discussed multiple topics today, starting from electric charge, interaction of charges, method of charging, charge detection, earthing, lightning, and finally earthquake. So that's all about today's class, and I hope everyone really liked it. Please revise the concepts wisely. Please do subscribe, like and share with your friends and relatives. So that's the end of the class. We'll see you next class with an amazing session similar to this. Till have a nice day and goodbye everyone.